session of this morning. It is a pleasure for us to have Ash Ravikumar from CERN with us. Thank you, Ash, for being with us and for taking your precious time to deliver a lecture on entrepreneurship. Ash joined CERN's transfer group in August of 2019 as Entrepreneurship Development Officer with responsibility for managing the Business Incubation Center network and foster a culture of entrepreneurship at CERN. Prior to joining CERN, Ash held roles in business development and commercialization at universities in the USA and in Australia, and also with Honeywell in India. Ash holds a master's in electrical engineering and entrepreneurship from the University of South Florida in the USA. We welcome you, Ash, this morning to our course, and I hand the floor over to you.
Thank you. I think I've shared the screen. I hope you can see it all, or all of you can see it.
Yes.
Thank you for the intro. You reminded me my third year anniversary at CERN is coming up in about 3 weeks. So I've been at CERN for 3 years. Primarily, my work has been looking at early stage research from universities and commercializing them. So a lot of it is picked up, talking with a lot of really smart professors and researchers who've developed their research and commercialized it. So few things, I guess, housekeeping. At any point, any questions, feel free to ask. I know it's going to be a ton of information. So if you have questions later, my email will be in the last slide. Feel free to shoot me an email or LinkedIn, any of that works. So I've got, as in the intro, I've got 2 roles at CERN. One is to use our technology know-how developed and transfer it to industry, primarily startups, and also create more startups coming out of CERN. So, help entrepreneurs from CERN or interested in entrepreneurship to help them with their 0 to 1 issues. See if I can pull the slide. All right. So I've split this talk in 2 parts. One is, what I call starters. Another one is called joiners. So for me, starters are the ones who are, who take their idea or their invention to market. So i.e. they create their own startup. For me, growing up, when I was in my teens, when this ad came up and had a massive influence on me, this is Apple's Think Different commercial. I think it was in 94 or 95. Pretty much the quote that stuck to my head was, people crazy enough to think they'll change the world actually end up changing the world. And for me, the people who take startup ideas or their ideas to saying, well, we're going to build a startup around it, fit entirely into this category. And this is, for me, challenging, and I'll come back to this quite a bit. Amazing book. If you get this, I would highly recommend reading it. This is written by the first CEO of Netflix, and the title is "This Will Never Work," because that's what everybody told him. When they said we're going to stream videos, people said, well, this will never work. Who will ever watch a video online? Context, this was before internet had the bandwidth. And most entrepreneurs, when they go in the journey, will hear this multiple times. And to be honest, people get put off by saying, oh, well, everybody said this will never work. And my opinion, it's actually the other way. If you're working on a good idea, you should hear a lot more of this will never work, because it means that you're pushing the envelope on something that doesn't exist. So don't take this as, well, somebody said this will never work. Rather, if you're building on something worthwhile, you should hear this. And there's, what are my best examples of this would never work? I mean, I always wanted to put, SpaceX and Tesla, but that's very American and everybody knows about it. For me, this is a European company. And why this company? It's called HITR Aerospace. They're based out of Sweden. They were set up in 2018. That's 4 years back, right? The idea was to build a 19-seater electric airplane. One guy and his co-founder, 2 of them, came up with this idea. Simulated parts, you can't build a 19-seater prototype, right? And so it was all simulation work, theoretical work. what happened then was the vision was so big, they went and hired the best people in aviation industry, people from Airbus, the head of, their technology, their CTO has, heaps of experience with Saab Aerospace and whatnot. It ended up that, United Air Express has actually signed $50 billion worth of contracts with them, i.e. they've actually lined up to buy these. For me, can you imagine how many people said this would never work? Boeing and Airbus are going to build airplanes. You will never make airplanes. So for me, these are the ideas which push the envelope. Second example for me, this is American example, is a company called Commonwealth Fusion. They're a spin-off based out of MIT. They're building their fusion reactors. And they've raised so far $2 billion to build their first prototype to show proof of concept end of this year. For me, these are massive projects which were never possible and feasible within the startup world. But now this seems feasible. This seems possible to actually get funding to build big projects and attract big talent. So in the past 10 years, and I think there's been a major shift from your regular tech startups to what now it's called the deep tech startups. And I'll touch more on this, on jargons and TLA. TLA is acronym for three-letter acronym, because everybody likes to invent acronyms. I'm sure you all told everybody that you are in HITR Plus training for this week. Anybody outside of that realm would not know what HITR Plus is, right? I mean, I use acronyms all the time. Everybody is guilty of using it. But the problem happens is when you're outside of the bubble, either you're not an insider if you don't know the jargons, or that people keep on using those jargons where you'll have to end up going and Googling them. So for me, it's just to give a quick brush up on what are the jargons within the startup, so that if you are thinking about entrepreneurship, you get an idea of where it is, or at least the history of some of these jargon. So everybody now talks about deep tech startups. I mean, why this label? What other types exist, right? I mean, if you say I am a deep tech startup, what does that actually mean, right? And so I'll just walk you through a little bit of history, so bear with me. Initially, all startups were tech-based, right? And the definition of a startup was it was highly growing at like, the hockey stick exponential growth, and it is scalable, i.e. if you do this in Europe, you can do it in the US, you can do it in India, you can do it in Australia, i.e. it is replicable across all of these geographies. And I'll leave this question here for you to think about it. If you know the answer, when we talk about Q&As, we can discuss more. Why is it called Silicon Valley? Where did that word silicon come from? I'll give you the hint on the valley, because it was San Bernardino Valley, where Palo Alto in California was. But why Silicon Valley, right? So put the question when we talk about more questions. So then, all startups were tech-based, and then Google, Facebook, iPhone, all of that happened, and people were building apps, and they grew, they scaled tremendously. Think about, Candy Crush. They were also called tech startups, right? And so then they carved out and saying, no, these are all software-based companies. There are still some tech-based startups. And then post that, there's now WeWork came up, all of your software-based companies just become very big, and they still develop technology, i.e., if you think about Facebook, they started building a lot of tools for big data analysis. So two things happen. It's like, okay, it is tech, but it's still not deep tech, right? Where we are currently, where you have to, if you're working on semiconductors, that is deep tech. So, so those differentiations happened. Where the jargon comes in is if you go, if you're building on, heavy ion therapy, either software or hardware or accelerator parts, if you call yourself a startup, you're still going to be compared with Instagrams of the world. If you say you're a tech startup, you'll still be compared with Instagrams of the world. So you'll have to, use the jargon, well, I'm deep tech startup, because whoever you're going to talk to, then you puts into you in a separate bucket. Now, and that's where also, the jargons about entrepreneurship comes in. Every company is made by an entrepreneur, i.e. your local bakery is made by an entrepreneur, right? But for you to buy the bread, you have to go to that local bakery, i.e. I cannot buy from anywhere else in the world. It's very localized. So that's the differentiation where I put into small business necessarily. Um, Another way to visualize this is, entrepreneurship is the whole coverall. Everybody who ever starts something and doesn't work for somebody is an entrepreneur. And then there are startups under entrepreneurship, i.e. this out of the small business, you get those startups, which are high growth, high scalable companies. And then comes the tech startups where there is a technology, could be software as well, but there is a tech part of it, i.e. you need to code something. And then comes the deep tech startups, which is the smallest sector in there, which is either biotech, med devices, imaging, advanced materials, manufacturing, robotics, software, electronics, photonics, quantum, go on and on and on. So that's where, you need to differentiate that deep tech part of it. And that's where the jargon comes into saying, where do you fit into this curve? So what does a characteristic of a deep tech startup look like? i.e. that's built on novel IP. It doesn't have to be patented, right? So IP covers all intellectual property. It could be copyrights, it could be, secrets, know-how, and patents. One way to protect that is patent. So, but the underlying intellectual property is unique, has gone through rigorous research, and you can defend that research. The significant competitive advantage you get from that is if somebody wants to copy your idea, it will take them X number of years with X number of people to recreate that. And so that gives you an advantage. I'll talk more about solution and search problem next slide, but this is a very technology first approach, i.e. I'm going to fix this tech problem first, not necessarily the business problem. And capital intensive, talking to HITR Plus and the first animations, this is, if you want to build a MedOstron again, it is capital intensive, right? You need a lot of infrastructure, you need a lot of human capital, all of that costs money. You can't, build an app, launch it 2 weeks, and then, go to market soon. So it is capital intensive, i.e. even if it is software that you want to develop, you'll have to go through a lot of trials and testing before you do that. Many of them are developed in a lab, by which I mean you'll have one prototype or 2 prototypes that work, that you can replicate and you're confident. However, there'll be a ton of technical risks that will show up later in the product development, i.e. when you have to mass produce it, you'll have to get somebody else to manufacture it. You'll have to make a ton of compromises on trade-offs between performance, cost, quality. So there will be a technical risk later on, right? And so that's pretty much what the jargon's around it, so that and want to, if you ever build a startup and go down the entrepreneurial pathway within something that you're working on, research-based one, where do you want to position yourself on deep techs and why? And so these slides at least gives you the logic behind it. If somebody says, oh, you're not a deep tech, you can say, well, I fit these characteristics. And then if somebody says you're wrong, ask them to come talk to me. So example, right? So for me, this is a very close to heart for me. Once you see it, it's hard to unsee it. That's where I put it. A laser is ubiquitous. We use lasers, or we use products that use a laser across our life all the time, right? But we don't even realize that. Most of the communications through Zoom that you're seeing probably is through an optic fiber. I'm using a Mac, all the holes around the speakers are drilled through a laser. And if you had eye surgery, probably you use laser. So laser has become so ubiquitous that people forget that it's only 61 years old, right? There was a bit of controversy on who invented laser. There's, started as microwave, so Maser, and it went from 51 to roughly around 63. That's about 12 years before they made $1 million in sales. The reason was, at that point in time, it was a nice physics phenomena. Well, we've got this laser, we've got this coherent light that we can create, but we don't know what the application of this is. Within the startup circle, people throw this line all the time. It's a solution looking for a problem. There's many versions of this saying that, don't search for don't invent the light and search for a dark room. And the other way to look at it is, you have a dark room, how do I put a light in it? So um, if you're doing a tech-based one, you will fix that light bulb and then search for the dark room. And that's probably always what will happen. But what ended up happening was that, they started doing it for, first the application thought of was, welding of watch springs and watch gear wheels that they wanted to weld on. And somebody had an accident and, one of the nerves or, blood vessels was sealed perfectly. And a surgeon saw it and then called his friend and said, hey, you've been thinking about how to do LASIK surgery. Why not you try it? And that's where, how applications went. And one of the big case studies that was done on lasers, the outcome was, if you're building something, give it to the end users to play with it, i.e. that the surgeon doesn't have to understand the physics behind laser, but they have a problem and then you can fix it because you've got a way to do it and they own the problem and you help them fixing the problem. And then rest is history of how lasers developed. And I think there's about 19 plus Nobel Prizes awarded to do something with light after 1964. And then on the right is your unintended consequence. You click on it, it'll get you the actual patent behind using a laser as a method of exercising a cat, right? So you can patent for anything. They use the same laser pointer that you use for presentations, and somebody patented it to entertain a cat. Not necessarily a technical invention, not even practical invention, but somebody did file a patent for it. So I guess the point is, irrespective of what you invent, they will find some useless use for it. Go to the next slide. For me, this is the best visualization of how you move from the startup phase to what I call a scale-up phase. Whereas the startup phase, you iterate a lot of different things. You're doing, how does this market work? Will this customer buy? And you do a lot of iterations. And that's the messy part. And a scale up is when you can replicate sales, right? So for me, there's also another phase from a research side of it, as on the lab to a startup to a scale up. In the lab, you look at it and saying, this is my PhD thesis, or this is my master's thesis. You look at a problem and then you deep dive into it. Then when you publish and you look at these results and like, oh, look, I think we've got something out here, let's go talk. And then you start getting ripples about, maybe there's a bigger market here. And then you spin it out or set up your company and then go through the startup phase of mess. And then you come out of scale up phase. Again, I'm using quite a bit of jargons. Happy to talk more about it. And now to my favorite 3-letter acronyms. If you're looked at any entrepreneurship material, you'll see these 3-letter acronyms: MVPs, product market fit, PMF. This is my way of visualizing it, right? So if you're working in a lab, you're looking at, how does this, I've got this technical solution, I've got this problem, I've talked with a few people, how does this actually fit together, right? For that to show for it, I need a prototype. Within the software world, they call the minimum viable product, which means no bells and whistles attached to it. It's one product where I can go show to a customer, say, hey, this is how it works, you can trial it. But if you're building something hardware-based, or accelerator for that matter of fact, you still need to have a prototype where you can show that works, or enough simulations that is scientifically you can tell that this works. And that's where the MVP, or minimum viable product, comes. And that's where, if it proves that enough people say, yes, I like it, then you go into the startup phase, where the next 3-letter acronym is product market fit. What does a product market fit look like? I.e., if you find one segment in a big market to saying, okay, for me, I'm going to look at cancer treatment with these cancers because I've got better efficacy and I can control, and I've got data to say that this tumor reacts well to this kind of treatment, then you can replicate that across every place that has this problem. So you found your product and a market fit, and then it scales without you have to figure out and test your hypothesis nonstop. Then the scale up part comes in, where you actually do a channel to a product fit, where this is to saying that to get to my customer, this is the perfect channel to get to. And then you can say, okay, if I have a distributor who can sell to this person to my end user, or am I selling directly to my customer? That's where you'll have a lot more other acronyms, B2B, B2C, i.e. you are a business. Are you dealing directly with another business? That's B2B. If I sell directly to a customer, then B2C. And there are other variations of this, B2, B2C and all of that, which complicates stuff. But in essence, for me, this is a simplistic way to look at it and saying, what stage do I have to be when I cross these, imaginary thresholds, so that I can keep track of whether I'm going there or how I have to course correct towards to getting there. I'll pause here. Any questions so far? I feel like I'm doing a monologue. All right, then I'll continue. This leads, one of the biggest things that every entrepreneur who was a researcher looks at is, oh, find a problem worth solving. Well, how do you know if it is a problem worth solving? What is a big enough problem to look at solving, right? And so the link for this is a very beautiful write-up. It's a chap called Manu Kumar. He's based in Silicon Valley. He's an investor, but he writes brilliantly. So this is full courtesy towards his writing, which is a good framework to break this down to, right? So first part is frequency. Does this problem occur often, right? If you look at a problem that you're solving for, let's take, you need to do beam control. You can look at it and saying, well, does this beam need to be controlled? How often does this problem happen? Or if it is, you need to collimate the beam, et cetera, how often, or how does this problem occur? How many times, right? How often? And then the second option, the second thing for me is the density. So a lot of them have this problem, or is it that unique to this particular beam? Only these people have this X controls or Y controls. And so is this a problem only for this? Or is it have a lot of them have the same problem? And the third way to is, this is more important, pain. Do they care? Yeah, we found a problem that occurs a lot of them have it, but do they really care? It's just a small annoyance that I can live with it, right? Now, all of them leads to this. Once, okay, you found a problem that happens very often, a lot of them have it, and they really hate it. Now, your solution should not have any friction. How hard is it for them to access and understand your solution? Do they have to have special training? Do you need to have a PhD to understand what your solution is? So can you make it easier for people to understand it? So if you saw all the 3 slides, I've got them, they, and them again in red. Who are they? For me, it's the customers or your potential customers or your end users that would use your product, right? And this is the asymmetry problem for me to simplify the asymmetry problem here. You've got a very good product and then nobody knows about it, you still fail. You've got a really bad product and nobody tells you it's a bad product, you still fail. The only way to break this asymmetry problem is to go talk with them, and they will tell you that, look, it's a good product. Let me go tell my friends as well that this works. Or I love this product because of X, Y, Z. Or if it's a bad product, they'll say, well, this is not really what I was looking for. You need to go fix this so that you can actually reiterate. So I want to spend time to just reemphasize this. If one takeaway that you take away from this whole talk is talk with people outside the building. If you stay in your bubble, it will do all the confirmatory bias that your original assumptions had. You want to go test your hypothesis with people who will actually use what your solution is. And that's absolutely important. And that's the one thing that makes or breaks a startup. This is the second part of the slide. And then I just want to break here for a couple of questions. If anybody has, I can't see everybody's face. So that's why any questions so far?
We can take some questions now. Who
right.
has any questions?
I'll start share again.
We normally take them at the end, but it's not a... Is there anyone who has a question?
All right. Look, I understand. I'm not forcing everybody to ask a question. My view is, it's a ton of information and I speak pretty fast. So if I'm going fast as well, ask me to slow down. Uh, all right. So this is the second part where I want to talk more about the dogma, existing dogma, right? So the existing dogma is, if you're a researcher, you found something, you have to go create the startup, right? I don't completely agree with that as a singular option to do it, primarily for two reasons, right? You've already solved the hardest part. That's the technical side of it. Now you'll have to go understand sales, you'll have to understand marketing, you'll have to understand HR, all of that as a startup. My throwaway line is, you don't want to teach Einstein, credit and debit. I mean, that's not what he has to be an expert at. So the other part is joining startups, right? One of the key problems, all startups need talent, irrespective of, actually all companies need talent. You need to have the best people come join you, and there's a high risk that your company will fail, right? I'll repeat again. You are a startup with 2 people, 3 people, you don't have money coming in, you don't have enough capital, but you want to attract the best people to come and join you. And you're competing with all the established companies already. So this provides a big challenge for startups. So if you are looking at like, look, I'm interested, but I don't want to do startups, I don't want to be an entrepreneur, there's always an option to join these startups. None of these companies are successful because they have, a CEO to do it. It's the actual team who does it. So if you're looking at, how do I join these startups? Where do I find these startup jobs? First disclaimer, most startups don't know what they're looking for, right? By which I mean, look, we've got 3 people, we are doing this. Do I need another technical expert? Right now, I don't know. Or my expertise is in accelerator design, or my expertise is in this particular niche that I've been working on. You'll never be a one-to-one match. I think it was Sheryl Sandberg who said this: if you're offered a seat on a rocket ship, don't ask which seat to sit, right? If it is a startup, there will be a lot more of activities within the startup. You have to roll your sleeve and do a lot of different things. That being said, reach out to good startup founders who are in your field. Look at companies who are building software for hadron therapy or making new accelerator designs, et cetera, et cetera. Reach out to the startup founders and say, hey, look, I'm doing my PhD in this. I'm not sure if you're recruiting for this, but if you are, let's have a chat. Most startup founders will absolutely love for those inbounds to come, because that's validation for them that somebody who's got a PhD is actually interested in what you're doing. So first, for me, is always go directly to the source. Directly start talking to the CTOs or the CEOs of companies who you really like, and you tell them why you really like what they're doing. And this is a high-level match than going through any recruiter or any other advertisements. So this is early-stage companies which are less than 10 employees in my head. This is a fantastic source called Angel List. They kind of revolutionized how you raise venture capital money. Before, it was always controlled by a handful of people who had money to do it. They kind of democratized so that you can create a syndicate with a lot of angel investors, and they gave the entire framework and the legal framework to do it. And then they saw all of these startups had one thing in common, was to get best talents join. And it's global now. Based on wherever you're in the world, you can look for startups who are looking for jobs. Note, this is, you might have to go look at, hundreds of it to find certain things within the deep tech space, but this is, a good resource to know that this exists. And the third, and I'm almost the final part of my talk, I think I've got only one more slide left after this, the venture capital firms. I'll pause here, and I think I can talk for hours on this particular topic, right? So remember, I talked about Hart Aerospace and Commonwealth Fusion. They need to raise a lot of money to make it before they actually will get revenue, i.e. you'll have to pay for bills, you'll have to pay for salary, you'll have to pay for prototypes. So you need capital. As I said, all of these deep tech startups are super capital intensive. So who pays for this? You can't get a grant to do this. You can't go get a bank loan because you have no assets in your company. You don't have a product. You don't have a balance sheet. Um, the European Union has a few programs here in Europe to support early stage startups. I think there's the EIC scheme, which this is about 30,000 initially, and you can get up to 2.5 million euros on the second stage, and a lot more other direct investment systems are also existing within the European Union. But there is this other category called the venture capitalist. These are people who will write investment into your company and they'll own a part of your company for that investment. And they don't get paid till you're actually successful. So they've got a big vested interest for your company to succeed because they own 20%. And if it goes to zero, they own 20% of zero. So they want to own 20% of $1 billion company. So what they've started doing is, this is Index Ventures, one of the biggest venture capital firms. They're based in Geneva as well, or at least the founder of it is in Geneva. This is the screenshot of their job portal. They've got 7,766 jobs across all their startups that they've invested in. The question is, why are they doing this, right? Because if the best people don't work on their startups that they've invested in will fail. What was so interesting for me about them was I spoke to somebody in their firm called the director of talent. I'm like, what is a director of talent doing in a venture capital firm? So that was my first question. He said, well, my job is to teach the head of HRs in all of my portfolio companies on how to hire good. Rather than giving them a fish, I teach them how to fish. For me, this was fascinating how this venture world has evolved as well, that they have somebody in-house to teach all of those young startup companies on how to set up hiring processes, how to do legal well, so they actually give full support on this. Excuse me. So if you go to their website, you can do multiple searches, geography, specification, company-specific searches as well. And thanks, my email is there. I don't think the URL worked, but I've kind of the only Ravi Kumar at Sun, so that helps. So find out, and happy to connect on LinkedIn anytime that you want to ask questions. Wow, I did talk fast.
Okay. So do I have any questions for Ash? Maybe I can start with a question myself, Ash. Let's say we have an idea. We're scientists, right? I have an idea, for example, for a new detector, and I have also thought of an application. Where do I start from, actually?
So first is go seek help, right? So if you've got an idea that you've actually jotted it down, written it down somewhere and saying, I've got a new detector idea. Why is it better? What is a technical problem that you're trying to solve? Write that down. And if you work at a university, go to the tech transfer office. You're working at CERN, come to knowledge transfer. The two first things I would do. One is, do you want to protect the idea? Do you want to stop others copying the idea? So if you want to protect it, then you go through the patent route. To find whether it's patentable, you need to saying what else exists out there. So they call the prior art analysis, to saying, is this patentable? And then work out a patent strategy to saying, okay, I'm going to file this, spend money to protect this invention. And then comes a fork in the road for me. One, do you want to set up a company and manufacture this, sell it? I.e., do you want to own that as a company? Or do you want to license it to an existing company who will take the idea, build it? The more they sell, the more services they do, they pay a royalty back to you. So that's the two different options. And there's also a hybrid option where you set your company up and you license it from the company. Well, that's kind of the complicated part. But let's keep it simple. You've got two different options to do. Now, my sincere suggestion, so that I've given you the whole steps, right? But the first step is to go talk with someone to saying, I've got this idea. I want to know if I can protect this. What do you think, right? I always insist this. If you talk to only either your friends and colleagues who are either researchers, they will look at the technology part of it. Great, you'll get some validation. That's fantastic feedback. But get outside of the building, talk to somebody outside of your bubble so that you are not guided by your own confirmatory bias, because you're going to ask the question expecting the answer. So, if I throw it and saying it's a sunny day, isn't it? You will say yes. So I know the answer. So I'm going to ask a leading question. But if you go talk with somebody you have no idea about it, then you'll actually have to explain to the basics on why your new detector design is better, right? And so that feedback loop is super important. Most tech transfer offices help you to find and validate that part. Sorry, I was going with a very long answer. I kind of wanted to pause to ask Nicholas, did I answer your question?
Absolutely. Yes, yes. Are there any other questions? I have other questions myself, but
Brilliant.
are there any other questions?
Manjit had a question.
Yes. So Ash, as you know, most of us as scientists, we don't know what an idea that can be patented or is exciting for the outside world or not. I mean, this is one of the fundamental things that we come from the environment where most of the students are in. And we all think our idea is always great, by the way. That's why we do research. So how do you know what sort of things can you do as an acid test to see if the idea you're thinking about makes any sense at all, or we should just carry on doing our research, do publications, what we're good at? How do you know?
Right. So, so for me, this is where if anybody says there's a simpler way to do this, they're lying, right? Because this is not science, it's not universal fact. It's where most of the things I call the business becomes art, i.e. there's no definitive answer. For me, I'll just go back to my previous experience and then I'll answer this question as well in detail. Every year when there was this massive SIGGRAPH conference, I used to get about 80 new invention disclosures from the professors at the university. The reason was, oh, my publication is being selected. I've got to go present and talk, which means that my peers all thought this was a good idea. Maybe there's a commercial potential to it. I don't know, but my friends in this community thinks it's fantastic because I've been invited to talk, right? And so when those 70 comes and hits you in one day, and that's where my stress level goes up, because then they're going to go talk in a week. I'll have to do the independent analysis on each of those to say, is this protectable? Is this make sense? And you wouldn't have the time to do it. So what we used to do was file all of those in the university to saying that let's do a filing and then do the evaluation later, because there's no way to do it. But to answer your question, where I or anybody that I know in the tech transfer cannot answer to saying if that's inventive or not, or has a market potential or not, because by definition is an invention. So there's nothing that exists to compare. And if anybody tells you otherwise, they're lying. And I'll stand by that word, right? And one of my first mentors, the best advice she gave to me was, know these 3 words because those are the hardest thing to utter. I don't know. Once you say that, you actually will go figure out how to find out, right? And so that's the first part of the answer. Second part of the answer, my view, always what I did was go and ask help from somebody who is in that industry, right? If say, suppose there's a new detector design, ask somebody who is a expert within the detectors or who buys it in that industry to say, hey, look, this is what we have. What do you think? Either you put a non-disclosure agreement with them, or if you're having a patent file, then that idea is protected to saying, if this works, what do you think? Or for this to work, what do you think are the next natural steps? That gives you a clear path from the other side of the industry to saying that you achieve point A, point B, point 3, then the technical risk of it is down. We will buy it, or we will use it, right? And so as a scientist, a lot of pushback has been to saying, oh, scientists should figure this out. And I don't think that's the scientist's role, right? Scientist's role is to figure the science part of it. Hopefully there is an office or people within the universities or the research institutions who do this so that, hey, I've got this, what do you think? Oh, I don't know. Let me go talk with somebody who might know this. Do you know anybody else who might know, so that I can go have a proper chat on the business side of it? And so that has to be that feedback loop. Otherwise it's made up, fantasy answer.
Now, the reason I was asking, as scientists, when we have some new ideas, we like discussing, okay? And of course, what you're telling us, we shouldn't discuss if it's really an interesting idea, because we don't know. We like discussing our work. So who can you discuss with before we come to the KT office?
No, look, so for KT office, please come talk, right? There's no so please discuss. I don't want that takeaway to be don't discuss. Please discuss with your peers, discuss with the KT office, right? I am a huge proponent on open source commercialization, right? I mean, the existing dogma is if you don't file a patent, you can't license stuff. That's not necessarily true, right? I can give you a lot more examples of open source commercialization that has worked brilliant. If you take hardware, the whole Arduino market is entirely built on open source hardware commercialization, to Red Hat Linux, which was the biggest software company ever been sold on, built on open source software. And then that's like $34 billion that IBM paid to buy Red Hat. But then as you also have MongoDB to, Elastic to everything else, they're all built on pure open source software. So patent protection or protecting your IP should not be the biggest detriment towards commercialization. So again, just to make sure, please talk with people. The more people you talk with, more validation you get, you can proceed with. If you have a tech transfer office, if you talk with the tech transfer office, it's not considered public disclosure. So you can still patent protect it because you're all in the same organization. But if you talk with outside and say, hey, a company comes and says, I think I can talk with them, better talk to the legal office or the tech transfer office to saying, should we put a non-disclosure so that they don't steal the ideas. So that would be a good first step.
Thank you.
Cheers.
Joe.
Okay, so we have a question from Jota.
Yes, if there are no other questions, just a real life example and guidance. I don't know if you are aware of this linear accelerator that we're working on, particularly with alpha particles to produce astatine. And that was a real life example where we thought maybe we should patent it or something, because we know that is something that does not exist. We have seen in the literature that there is a demand. Actually, astatine is not, at least so far, available for research because of lack of accelerators. And we have a good design. By chance, that many RFQs plus this plus that came exactly to the energy that we needed. And the first idea was, yeah, let's see if we patent it, right? But then it was like, oh, forget it. That's too much, and all the administration, the bureaucracy, and after all, we are scientists. And of course, we present it to IPAC, and we do posters, and we write papers, etc., etc. I mean, for us, this is the usual way it goes, right? I mean, what do you have to comment on that? And we have not done cost estimates. We have a rough idea about cost estimates, right? Yeah.
Mm-hmm. So for me, there's now we're going into more into the patent side of things, right? And I'll give you an engineer's answer. For me, if you ask me to define an inefficient system, I will define that as the existing patent system, the patent laws, right? So bear with me, it's a long answer. So the patent system was designed, in the 1800s, where there was the best invention was a printing press at that point in time, or a rotating gun, or then came the mechanical inventions where the patent process worked, i.e. you define part A, part B. The system as a whole broke when you started getting software, drug discovery, gene therapy, et cetera, because the existing patent system could not help it. Now it's become such a complex beast that the patent system, my opinion, it's recorded, so I'll say it on the record, it helps the lawyers, right? The patent lawyers make them a lot of money when they write it. When somebody infringes, you go to the lawsuit, lawyers make money on that. So it's an entire system built and run efficiently by the lawyers. Now, that puts a lot of constraints on the patent decision, whether you file it or not. That's because it is expensive to write it, file it, and prosecute it in multiple countries. So your estimation on 20-year cycle, if you're filing in multiple countries, could be 100,000 euros to 500,000 euros if you have to translate, et cetera, et cetera. So then it becomes a cost factor. If I'm spending $500,000 to protect this invention, at least it should break even to get the $500,000 back, right? If it doesn't, then you're doing a bet on saying, I've got only $500,000. Do I put money on this patent or do I put money on this patent, right? That's the first part of the answer. Second part is, what do you do with the patent, right? So the good side of the patent world is that you can license it to somebody to manufacture and sell it. And if they manufacture and sell it, they give you a royalty back. But the dark side of it is somebody reads your patent, reads your article and saying, you know what, they have a patent, I'm going to infringe it either way. So then you have to go to court and sue them to saying that you are infringing, you have to stop selling this product, and then ask a judge and a jury in the US to find that your idea is actually infringed by them. You've got proof to get that money back. And that is a long process, and in a factor of time equals money when you go to a lawsuit, right? And so though that's the money equation that comes in when it comes to the patent world, right? That's the necessity. And I want to just highlight the jury part of it, because in the US, if you go into a lawsuit, there'll be 12 people selected from randomly. And imagine you have to explain a linear accelerator to do alpha particles for this energy and compare it to the other technology, what they copied, and convince them that they have infringed. That is the biggest challenge, right? So at a university where I worked before, we did a mock trial on a chip IP block that was infringed. We did 2 mock trials, 2 different juries. After a month, they didn't understand what a chip was, leave it on another IP block or an ADC or what was, so that's a big challenge, right? And so having a patent is not necessarily the end answer to it, but it helps if you go into lawsuit that you actually have a protectable right that you can enforce. So that's the long answer.
And what would be the advice? Which way to go?
Look, anytime for me, if you have a patentable, if you think you've got a novel invention, the best way is to go figure out, can you patent this or not? If there is a market, if somebody says, if you patent this, I will license it. You want that feedback loop to make the decision. You've got a lot more data points to make the decision. So the advice is go talk, figure out if you can patent it, and figure out an IP strategy. If the IP strategy answer is there's no point in patenting this because it'll take us 20 years to build it. By the time we get to 20 years, the patent would be invalid. Might as well put that 500,000 into developing it more so that we can actually license the know-how, because nobody can read a paper and build a new detector. They need to have our know-how to build it. So they'll actually come and pay us more. We can fund more research, pay for more postdocs, that loop. So it's a cost versus benefit decision. So, but it's always best to have the discussion to figure out the strategy. So the advice is it's not a single one answer. It's multiple based on the conditions and the parameters that will help us make the decision.
Excellent. Thank you very much. Is there any more questions from the students or anyone else? Can't see any in the chat, and there isn't any in the Slack, but I think if there isn't, and there isn't really any more from the board, that was, thank you very much for all your answers, Ash, and for the really interesting talk. I think we'd like to take a group photo. Oh, is there, Nicholas has his hand raised.
Another question, we'll have some more time. With regards to patenting, what are the costs like? Let's say I am not affiliated and I want to start up my own startup. I'm an individual. So here we have many early stage researchers actually. So let's say they have an idea, they're not necessarily employed, and they would like to protect it. How do they patent actually? It is very expensive, isn't it? And it's not only the patenting costs that are expensive, it's also, I mean, let's say a large multinational infringes your patent, or you think that even defending the patent is very expensive. How do people go about that?
So it's not a simplistic process, and that's by design. That's why I said the lawyers built the process, right? And so let me break it down on a few things. the patent process or the patent filing costs are really, really cheap. And the reason why they're really, really cheap are because you want the independent inventors to protect their invention. It should not be the only the corporations, right? So if you look in the US, to file a provisional patent application, it costs you $110. That's it. And if you are a university or a nonprofit, it's half the cost. So 110 by 2, $55. And if you are an independent inventor, where you can prove that you are a single person, you're not affiliated with anyone, you get what is called a micro entity status. So you get 75% of the filing fee knocked off. Now, to my previous estimate where I said it takes 100,000 to $500,000, where does that money come from? That is where the lawyer fees comes, right? A half decent patent lawyer would charge you $300 an hour. And for them to write the patent document, it will cost them, or they'll be charged at least minimum 10 hours of billable time. So 10 hours at $250, that's $2,500 that you have to pay on top of the 110, right? And so once you file it, and then you file a PCT, which is with a VPO, that's $2,500. So it adds up, right? And say, if you say, I want this, the biggest market is in Japan, and you've written your whole patent application in English, you'll have to translate that into Japanese. So you'll have to tell your lawyer, hey, I want to go to Japan. They'll find a translator in Japan. They translate it, send it back to them. They send it back to you. Every time they touch it, they'll charge you, it takes them 8 minutes. That's $250 divided by, 8 minutes equivalent, and you will get a bill for it. So every time they touch something, it adds up. So as an independent inventor, you can do all of this, cut the lawyer out. Where do patent lawyers then fit in? The best example I can think of, from India, it's Sanskrit. From Europe, it's Latin, right? These two languages were never spoken by normal people, but a few specific elites spoke it. And so for you to get anything in Latin, you need to know Latin, otherwise you don't belong there. Patent law is the same thing. I can write in English and file a patent application just like a scientific journal, but the fear of, the claims don't read well, you need to have, how do I put it? The claim language is all legalized. So even if you write something in a technical presentation, it'll get into legalese mumbo jumbo to be filed into a patent application. So that's where the cost comes from, to be honest. So all of that to your specific question. If I'm an independent inventor, can I file my own patent application? Absolutely. Last time what I did was I pulled all these legalized mumbo jumbo into, the same text that is used in all the patent applications. I made it into a template where I used to ask the postdocs to say, hey, write your invention in this thing so that we don't get charged extra 2 hours by these lawyers because they're just going to use our same text. So, happy to share that, word file with people who want to write and file their own patent applications. But when people are getting interested, do get a patent lawyer. I would strongly suggest getting a patent lawyer, but at the provisional stage, nobody reads the patent application. So we can have a much more detailed discussion about the intricacies that happen within the patent process. Your second question was on multinationals infringing and suing you, right? There are two parts to it. One is, if you are an independent inventor or you have your startup and a big multinational sends you a cease and desist letter saying that what you're doing is infringing on their patents, that's kind of the best validation you can get. You are a 1-person or a 2-person company doing something which is carrying a $20 billion company, which means that whatever you're doing is worthwhile. Either go talk to their competitors, which means that they will license your stuff and they'll go into a big patent war. You can sit back and watch, or you can still go fight it into court, right? You can go raise money to saying that, hey, look, I am 1 person sitting here and I'm scaring, company X, which means that what I'm doing is right. I don't have money to fight this out. Would you bankroll me to fight? And there's a ton of examples of companies and private equity firms backing people into lawsuits. So that's one option. The other actual option is, look, I don't want to fight you, buy me out. I've built some something inventive, which obviously you want. I don't want to fight. You take my stuff, buy me out, and so we're good. So there's that multiple options to do as the way how to get out of infringement. Or if they really say, no, my entire role is so that you stop, well, that's the end of the road.
So if I understand correctly, if I were to file a try-it patent, of course, it will be expensive, but it's not going to be $100,000. Am I understanding when that is somehow? So we're talking about 10,000.
Yeah, absolutely. Look, so if you file your own patent, and the complications, as I said, is coming when you file in, Japan, China, India, US, Canada, blah, 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 all these, or even Europe, you have to choose UK separately, France separately, Germany separately, and you have to translate into the languages. So either you need to find, a patent attorney, or you need to, once you go into that complications, you need paralegal support. That's the disclaimer. Now, coming back to your question, yes, you can file across using the base minimum amount to go into, filing your own inventions. The two things which I want to just clarify, I know we have 2 minutes, so I'll make it really quick. The provisional patent gives you 12 months of rights. It's provisional. Nobody reads your patent application, you file it, and it's like reserving a seat, where people, you put a handkerchief to saying that's my seat. That's pretty much what it is. And after 12 months, you'll have to file what is called a full patent application. That's where you'll have to elaborate a little bit more. My suggestion is, if you're an independent inventor, use the first 12 months to call whatever you're doing as patent pending, because it is patent pending. That's why it's called a provisional patent. Provisionally, you are given these rights. And for the 12 months, you can actually go check with people to license it if they want to work with your idea, rather than waiting to spending all the $10,000 across the whole thing to saying, then I'll go talk with the company. You've got your idea, you want to go find somebody to pay for it, and you use your 12 months runway to go find this validation. And if somebody says, oh, this is exciting, then you can get the licensing agreement, you'll have money, get a proper patent attorney, that loop goes.
Thank you very much, Ash. Okay, if there aren't any other questions, we will take a group photo now. Ash, it would be nice if you stay here with us.
Yes.
And I thank you very much for your very interesting talk, very topical for our students.